we are going to discuss about linear regression. What is linear regression? First, we are going to discuss about the mathematical part of the linear regression. I'm assuming you already know some of the intuition about linear regression. So, first, what is linear regression? Linear regression is unsurprisingly the linear relationship between data, and linear regression is of three types. First is simple linear regression, multiple linear regression, and polynomial linear regression. In this video, we are going to cover about the simple linear regression. So, for simple linear regression, we can take two data. First is called the input data, which is also called the independent variable. It is independent of the other column or the other data, and the other data is the other data which we will take is called the dependent variable. The dependent variable is also called the output variable. The desired result for which we want, the target, is called the dependent variable. For example, we can see in this graph CGPA and package. CGPA is in x-axis, which is the independent data, and package is the dependent data because package depends on the student's CGPA. First, we can see that we have written the different CGPA of students, and these are the packages they got. You must be wondering why the student with less package have got the less CGPA have got higher package, because in real world data set, real world factors are there. That's why we see many anomalies in the data. But nevertheless, we have to find the relationship between them so that we can predict for any other CGPA. Here, what we can do is draw a straight line so that it will cover most of the data, and we should draw that line such that it should cover all the points and should not be very far away from any of the point. For example, we can draw a straight line here like this. You can see this covers most of the points, and it should have very least amount of error. This part is called the error. We will discuss more about it. Here you can see the package of the student with CGPA 6. He have got a package of 11 LPA. This package is in LPA, and but if we draw a dotted line to the dotted points to the line, we can see that he should get nearly 9 LPA. So we predicted 9 LPA, but he has got 11 LPA. So what will be the error here? Error is 11 minus 9 is equals to 3. 3 is the error we got in our predicted line. How we define this line? This line can be defined, this line can be represented as the equation y is equals to mx plus c. You must have seen this equation everywhere in your high school. So first, what is y? Y is this axis, x is x-axis. Here we have taken CGPA in x-axis and package in y-axis. We have to predict this, and c is the intercept. C defines, assume that a student have got 0 CGPA, but still he will get some package. So this defines that some package. And how we will find the y for this? Which y is what? Y is the prediction we will make. For this y, we draw these dotted lines, and we predicted 9 but we did it using marker. but what if we have to do it with maths? So we will use this equation, and to find out y, we can solve it using different methods. First is OLS and the other is called gradient descent. OLS is ordinary least square method. It is a closed form of solution. What is a closed form of solution? First, closed form of solution is those equations which are direct to solve. We can solve it directly and get the solution right away. But gradient descent is something else. Gradient descent involves a step-by-step process, and we gradually reach to the final solution of it. But we are going to first solve it using the OLS method, which is ordinary least square. First, we will see what is error function. Error function is E is equals to yi minus yi cap. What is yi? Yi is the actual data. Actual data. What is the actual data? Actual data is our actual package that a student has got. But yi is our predicted data. Predicted data. So error will be nothing but error is equals to actual minus predicted. We did it here also. Actual minus predicted. So let's see more about this error function. If we can reduce this error, we can get the line that fits the best in this. If we can get the best fitting line, we can get the best model for linear regression, and we will get least error, and we will get the most accurate results. How to find error? I said that this distance from the point to the line is the error, because what we thought is, if we, let's look at the first data we took, that is 6 CGPA, and this student got 11 LPA package. But according to us, this student with 6 CGPA should get 9 LPA. So the distance from this line to this point perpendicular is the error we can get. But we need to find the full error function. How we can find? We can take these lines D1, D2, D3 and D4. So error will be equal to, error E is equals to D1 plus D2 plus D3 plus dn. But if you look carefully, here D2 is negative. So if we don't take the mod or the square of this D, this will cancel out, and we don't want the error to cancel out. So what we will have to do, we can square it. E equals to D1 square plus D2 square plus D3 square plus dn square. You must be thinking why we did not take the modulus of this D, because if we take the modulus of D, what will happen is, the error function will look something like this if we take the modulus. And if the error function is something like this, then it is not differentiable at 0. But if we take the square of these errors, d1, d2, d3, dn, then the error function will look like this, which will be differentiable at 0. Therefore, that's why we take the square and not the modulus. Now let's solve it further. Here we can write it like this: E is equals to summation of I is equals to 1 to n di whole square. What is d? D is nothing but yi minus yi cap. So we can write the error E is equals to yi minus yi cap whole square. I is equals to 1 to n. This is our error function. Where what is yi? Yi is the actual data. So yi is the actual data and yi cap is the prediction we will make. So what is the prediction? This is the line equation. This is the prediction we will make. So we can write this or this. Actually, we write this into this. Here, summation I is equals to 1 to n is and we can take yi minus yi cap is nothing but mx plus b minus mx minus b whole square. Where x is our given data. Like for us it was CGPA, so we can put the CGPA in x, we can put the b is nothing but intercept, and m is slope, where yi is the actual prediction, and we can calculate the error. But how can we minimize this error? We will look more into it. We will have to first see this graph. The error function will look like this, because it is a quadratic equation. Quadratic equation looks this is a quadratic equation, and for quadratic equation the graph is bowl shaped. For this function, what we can do to minimize it is find the minima of this graph. For this we got this equation, but here we should write xi, because this is a general formula for all the errors. So for CGPA at ith position, its error will be equal to this, and we will have to do summation, and we can find the error function for that data set. So we need to find the differentiation of this bowl shaped curve. For the bowl shaped curve, for finding the minima, actually what we used to do is find the double differentiation, and we used to see if that will be greater than or equal to 0, that will be called the minima. But as I said, this is a quadratic formula, like something like function fx is equals to ax plus x square plus bx plus c. This is something like this. So for that, if we take the differentiation, this equation first we should discuss about this equation. This equation tells that this will be plotted like a bowl shaped curve. These two equations have the same type of graph. If we take the differentiation, we will get something 2ax plus b, right? And if we take double differentiation for this, we will have 2a. For every a which is greater than 0, we will get double differentiation greater than or equal to 0. This is nothing but minima. Now we have understood that when we do double differentiation of this quadratic formula, we will always get minima point. This is the global minima for this inflection point is the minima. It will always remain minima. In this equation, we will not find any maxima, so we will not do double differentiation. We can directly do single differentiation and equate it to 0, and that will be our minima. So let's write E is equals to summation of this. What we have to do is differentiate E with respect to B. First we will differentiate it with respect to B. dE by dB equals, we will apply the chain rule here. What chain rule says? 2 will come outside and we can write it as it is, and then differentiate, multiply it and differentiate the whatever written inside this braces. So 2 will come outside and this can be written whatever it was written earlier, and then differentiate whatever is inside this. So if we differentiate the first term, it will be 0, and the second term will always be will also be 0 because they don't contain b term, and this will give us -1 minus. So now we have got this for the single differentiation of E. If we solve it further, we will have -2 summation of yi minus summation of mxi minus summation of b. Right? We can write, we can break it into different terms and give summation to the variables, and at last -2 for we have to equate it to 0 for minima actually, and yes. So what we can do here to simplify it further, we can divide the whole equation with with n. So in the 0 side, if we divide 0 by n, that will be nothing but 0, and this side, if we divide by 0, it will be -2 summation of yi by n, where summation is from I is equals to 1 to n, and minus summation of summation from I is equals to 1 to n mxi divided by n minus summation of b with divided by n, and summation is nothing but I is equals to 1 to n, and we can see this will give us, wait, let me erase this. This differentiation dE by dB will give us -2 we can here -2 we can take this -2 to 0, and if we divide it, and it will become 0. So we can get here yi divided by n. Summation of yi divided by n is nothing but the mean of yi mean. Sorry, it is the mean of y mean minus m will be m, and x mean minus summation of b with n b divided by n will cut out the n, and we will get our equation equals 0. Here we can write b equals, we can take this negative b to 0 and it will become positive. B is equals to y minus mx, where y is y mean and x is x mean. This is the equation of b. Now, so finally we got the equation for b, but we also have to find for m, because m depends on y depends on both m and b. If we know m and b, we can find y. Y is the prediction we are making, and x is the data given. For example, we had CGPA. Let's solve for m. For the equation, we had that equation, error is equals to summation I is equals to 1 to n, that was equals to yi minus mxi plus minus b whole square. We have to solve for m with respect to m. So with respect to m, differentiation of this error function, what it will be equal to de by dm, because we have to find the differentiation. That will be equals to summation from I is equals to 1 to n yi, we have to apply again the chain rule. That will be equals to 2 and yi minus mxi minus b, and then we have to multiply this inner terms with respect to m. This term will be equals to m with respect to m, that will be equals to 0. With respect to m, this will be equals to minus xi, and this term will also be equals to 0 because there is no m term in it. So here we will multiply by minus xi. Now the final equation will look like this: minus 2xi we are differentiating and equating to 0. Here minus 2xi yi minus mxi minus b equals 0. We can take this minus to side of 0 and that will become 0. But here we have, finally we have summation xi multiplied by yi minus mxi minus b equals to 0. If we put this b's equation here, we can finally get the equation for m. We had summation of xi yi minus mxi minus b equals to 0, and we will have to put the value of b, that is summation I is equals to 1 to n xi yi minus mxi minus whatever the equation is here, y mean plus mx mean equals to 0. Finally we will have something like, we will multiply this xi to whatever this term is, yi xi minus mxi square minus y mean xi plus mx mean xi, and then we will take these m terms together, we will have summation we can take these common xi and xi yi minus y mean, and we will take m common here, so minus m xi, we will take mxi common, xi, and inside it m xi minus, again this will be plus x mean, that will be equals to 0. mxi plus xi plus x mean equals, because we are taking this negative term to 0, and that will become positive, and also we should not forget the summation. Here also xi yi minus y mean constant, m, we can take this m outside because it is a constant, and this will look like this, xi plus x mean equals summation of xi yi minus y mean. We can take this term to the denominator side of the equation in right hand side, m will be equals to xi yi minus y mean divided by xi plus x mean. We have got to the last point. Now we have to just do a small touch to it. Mathematically, we know that the differentiation of mean is equals to 0. So we can also write this equation in this form: xi minus x mean yi minus y mean divided by summation of xi minus x mean xi plus, we can take xi plus x mean whole square. Why we did plus x mean? Because mathematically, if we differentiate this, that will be also equals to xi, and this is the standard form. Now we have got both m and b. We can put those values, those m and b, and find out the y. So that's it for the simple linear regression. We can now code this part. We can put m equation and b equation and find out the y is equals to mx plus b. Whatever the answer for y will be there, that is our answer, and that is the prediction we could do by following the method of OLS, that was ordinary least square. Thank you.